Data mining algorithm. What I have chosen is the K-means algorithm, the most common clustering algorithm. K-means. K-means works by creating a K number of groups from a set of objects based on the similarity between objects. It may not be guaranteed that group members will be exactly similar, but group members will be more similar as compared to non-group members. As per standard implementations, K-means is an unsupervised learning algorithm as it learns the cluster on its own without any external information. Each item's metrics are inferred as coordinates in a multidimensional space. Every coordinate includes the value of one parameter. The parameter value's entire set signifies an item vector. For example, you may have patient records containing weight, age, pulse rate, blood pressure, cholesterol, and etc. K-means can categorize these patients by using combination of these parameters. The following section shows the working of K-means algorithm and it may be useful in your mini projects. Step 1. K-means selects a centroid for each cluster, for example, a point present in a multidimensional space. Step 2. Each patient will be closest located to one of these centroids. They form a cluster around them. Step 3. K-means recalculates its cluster center depending on its members. This center works as a new cluster centroid. Step 4. All centroids alter their positions so that patients may be reclassified around each centroid, similar to that in Step 2. And lastly, Steps 1 to 4 will repeat until all centroids remain in place and patients don't alter their cluster membership. The corresponding state is known as convergence. Here's a video of K-means clustering.
StatQuest, 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 StatQuest. Hello, I'm Josh Starmer, and welcome to StatQuest. Today we're going to be talking about K-means clustering. We're going to learn how to cluster samples that can be put on a line, on an XY graph, and even on a heat map. And lastly, we'll also talk about how to pick the best value for K. Imagine you had some data that you could plot on a line, and you knew you needed to put it into 3 clusters. Maybe they are measurements from 3 different types of tumors or other cell types. In this case, the data make 3 relatively obvious clusters. But rather than rely on our eye, let's see if we can get a computer to identify the same 3 clusters. To do this, we'll use K-means clustering. We'll start with raw data that we haven't yet clustered. Step 1. Select the number of clusters you want to identify in your data. This is the K in K-means clustering. In this case, we'll select K equals 3. That is to say, we want to identify 3 clusters. There is a fancier way to select a value for K, but we'll talk about that later. Step 2. Randomly select 3 distinct data points. These are the initial clusters. Step 3. Measure the distance between the first point and the 3 initial clusters. This is the distance from the first point to the blue cluster. This is the distance from the first point to the green cluster. And this is the distance from the first point to the orange cluster. Well, it's kind of yellow, but we'll just call it orange for now. Step 4. Assign the first point to the nearest cluster. In this case, the nearest cluster is the blue cluster. Now we do the same thing for the next point. We measure the distances, and then assign the point to the nearest cluster. Now we figure out which cluster the third point belongs to. We measure the distances, and then assign the point to the nearest cluster. The rest of these points are closest to the orange cluster, so they'll go in that one too. Now that all the points are in clusters, we go on to Step 5. Calculate the mean of each cluster. Then we repeat what we just did, measure and cluster, using the mean values. Since the clustering did not change at all during the last iteration, we're done. Bam! The k-means clustering is pretty terrible compared to what we did by eye. We can assess the quality of the clustering by adding up the variation within each cluster. Here's the total variation within the clusters. Since k-means clustering can't see the best clustering, its only option is to keep track of these clusters and their total variance and do the whole thing over again with different starting points. So here we are again, back at the beginning. K-means clustering picks 3 initial clusters, and then clusters all the remaining points, calculates the mean of each cluster, and then reclusters based on the new means. It repeats until the clusters no longer change. Boop, 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 boop. Now that the data are clustered, we sum the variation within each cluster. And then we do it all again. At this point, k-means clustering knows that the second clustering is the best clustering so far, but it doesn't know if it's the best overall, so it will do a few more clusters. It does as many as you tell it to do, and then come back and return that one if it is still the best. Question: how do you figure out what value to use for k? With this data, it's obvious that we should set k to 3, but other times it is not so clear. One way to decide is to just try different values for k. We'll start with k equals 1. K equals 1 is the worst case scenario. We can quantify its badness with the total variation. Now try k equals 2. K equals 2 is better, and we can quantify how much better by comparing the total variation within the two clusters to k equals 1. Now try k equals 3. K equals 3 is even better. We can quantify how much better by comparing the total variation within the 3 clusters to k equals 2. Now try k equals 4. The total variation within each cluster is less than when k equals 3. Each time we add a new cluster, the total variation within each cluster is smaller than before, and when there is only 1 point per cluster, the variation equals 0. However, if we plot the reduction in variance per value for k, there is a huge reduction in variation with k equals 3, but after that, the variation doesn't go down as quickly. This is called an elbow plot, and you can pick k by finding the elbow in the plot. Question: how is k-means clustering different from hierarchical clustering? K-means clustering specifically tries to put the data into the number of clusters you tell it to. Hierarchical clustering just tells you, pairwise, what 2 things are most similar. Question: what if our data isn't plotted on a number line? Just like before, you pick 3 random points. And we use the Euclidean distance. In 2 dimensions, the Euclidean distance is the same thing as the Pythagorean theorem. Then, just like before, we assign the point to the nearest cluster. And just like before, we then calculate the center of each cluster and recluster. Bam! Although this looks good, the computer doesn't know that until it does the clustering a few more times. Question: what if my data is a heat map? Well, if we just have 2 samples, we can rename them X and Y. And we can then plot the data in an XY graph. Then we can cluster just like before. Note, we don't actually need to plot the data in order to cluster it. We just need to calculate the distances between things. When we have 2 samples, or 2 axes, the Euclidean distance is the square root of x squared plus y squared. When we have 3 samples or 3 axes, the Euclidean distance is the square root of x squared plus y squared plus z squared. And when we have 4 samples or 4 axes, the Euclidean distance is the square root of x squared plus y squared plus z squared plus a squared, etc., etc., etc. Hooray! We've made it to the end of another exciting StatQuest. If you like this StatQuest and want to see more, please subscribe. And if you want to support StatQuest, well, click the like button down below and consider buying 1 or 2 of my original songs. Alright, tune in next time for another exciting StatQuest.
Here's an example of K-means problem solving.
Hello world, it's Rahul. Welcome back guys to machine learning tutorial. So we have seen so far how can we solve problems where we already have labels with us. But what if we don't have label in training data? So unsupervised learning came into picture that aids us in discovering patterns in our data related to various features. So guys, today we'll be going to study clustering mechanism where we organize objects into groups such that data points in same groups are more similar to the other data points in the same group and dissimilar to the data points in other groups. There are a lot more algorithms used for clustering the data points together, but today we'll discuss K-means clustering as this is the very basic one. So guys, K-means algorithm starts with initial estimates of K centroids, which are randomly selected from the dataset. The algorithm iterates between 2 steps assigning data points and updating centroids. Let's visualize all this, what I've just mentioned. Let's say I have some data scattered on the plane. So here I have defined data points in 3 different colors as these are creating different clusters when we apply K-means cluster on the data points. Let's first talk about the working functionality of K-means algorithm. Data is separated in K different clusters, which are usually chosen to be far enough apart from each other spatially. And for doing so, we use either Euclidean distance or Manhattan distance. Each cluster has a center called the centroid, and a data point is clustered into a certain cluster based on how close the features are to be centroid. K-means algorithm iteratively minimizes the distance between every data point and its centroid in order to find the most optimal solution for all the data points. So guys, let me mention few points what we have to do for creating different clusters for data points. First of all, K random points of dataset are chosen to be centroids. Then distance between every data point and the K centroids are calculated and stored. Based on distance calculates, each point is assigned to the nearest cluster. After then, new cluster centroid positions are updated, similar to find a mean in the location point. If the centroid location change, the process repeats from step 2 until the new calculated center stays the same, which signals that the cluster's member and the centroids are now set. I know it's quite confusing for you if you are going through this for the first time, but you need not to worry as I will show how can we form clusters on data points, how can we select centroid and K value. Let's look into the dataset and try to solve the problem. So guys, as you can see on the screen, we have dataset which is having height and weight column, and by finding similar patterns we have to cluster them together. Let's assume that we want 2 clusters for the given dataset. So guys, as I've mentioned that first of all we have to initialize 2 clusters as K is 2 over here. So here I will select any 2 values from the table randomly. Let's say I am taking row 1 and row 2 as my 2 clusters. So centroid for cluster 1 will be 185,72 and centroid for cluster 2 will be 170,56. Now we have to look into other data point as well and assign them into either cluster 1 or cluster 2. But question arises, how to do that? So we will find the Euclidean distance for row 3 with cluster 1 and cluster 2. And we already know the formula for finding the Euclidean distance, that is square root of x of h minus centroid 1 plus square of x of w minus centroid of 2. Now we will calculate Euclidean distance for row 3 with both cluster 1 and cluster 2. So Euclidean distance for row 3 with cluster 1 will be square root of 168 minus 185 whole square plus 60 minus 72 whole square, and it is calculated as 20.80. Now we will calculate Euclidean distance for row 3 with cluster 2 as well, and that would be square root of 168 minus 170 whole square plus 60 minus 56 whole square, that is 4.48. So as you can see, Euclidean distance for row 3 with cluster 2 is less as compared to cluster 1. So row 3 will be assigned to cluster 2, as we need to assign to the nearest cluster as mentioned earlier. As row 3 has been assigned to cluster 2, now our centroid value will get changed. We will take mean of 170 plus 168 divided by 2, comma 60 plus 56 divided by 2, and now our updated centroid value will be 169,58 for cluster 2. Now we will check whether row 4 will go to cluster 1 or cluster 2. Let's calculate Euclidean distance for row 4 with both cluster 1 and cluster 2. For cluster 1, square root of 179 minus 185 whole square plus 68 minus 72 whole square, that is 6.32. And for cluster 2, square root of 179 minus 169 whole square plus 68 minus 58 whole square. So guys, if you notice here, I am using updated centroid value for cluster 2, and after calculating this, we will get it as 14.14. So Euclidean distance for row 4 is less in case of cluster 1. So this row will be assigned to cluster 1 only. As data point has been assigned to cluster 1, now we will update the centroid value for cluster 1 by taking mean of centroid value and row 4 value, that is 185 plus 179 divided by 2, comma 72 plus 68 divided by 2. And now our updated centroid for cluster 1 is 182,70. Likewise, we will repeat the same steps till we complete for all the data points. At the end, we will get two clusters as shown on the screen. It will cover all data points and final centroid values as well. Thank you guys for your time. Do like, share and subscribe. Hit the bell icon to get the latest updates. Happy learning and stay safe.